Hi everyone. Let's look at two more examples from section 4.1 on finding extrema on a closed interval. In example 3, they ask us to find the extrema of the function f of x equals 2x minus 3x to the 2/3 power on the interval -1, 3. We worked on problems like this before the break, and we said that in order to find extrema on a closed interval, what we need to do is find the critical numbers of the function in that interval. The critical numbers are the places where the function's derivative is either equal to 0 or undefined. Evaluate the original function at those values, as well as evaluating at the endpoint of the interval, and that the extrema will come from those sets of outputs. Let's begin by finding our derivative so we can find the critical numbers. For this particular function, f prime of x, it's going to be a simple power rule. The derivative of 2x is 2, minus the derivative of 3x to the 2/3. We'd use the power rule. You bring the 2/3 down. 2/3 times 3 would be 2. X to the reduce the power by 1. 2/3 minus 1 will give us -1/3. So this is going to be f prime of x. If we wanted to, we could simplify it just to get rid of that negative exponent. It would be 2 minus 2 over x to the 1/3 power, or you could even call it the cube root. From here, we're now going to find our critical numbers. We will first look for the critical numbers where f prime of x is equal to 0. So we take the derivative, set it equal to 0. This equation that we're now going to solve is a classic equation where you have a fraction. Let's multiply both sides by the denominator to clear the fraction off. So I'm going to multiply both sides by x to the 1/3 power, x to the 1/3 power. On the right hand side, we're going to get 2x to the 1/3 minus 2 equals to 0. From here, we can get the x by itself. We have 2x to the 1/3 equals to 2 by adding 2 to both sides. Divide both sides by 2. We get x to the 1/3 power equals to 1. And then to get the x by itself, you can think of it as a cube root. So we're going to essentially be cubing both sides. And what we would find is that x is going to be equal to 1. So one of the critical numbers for this function is going to be x equals to 1. We will also have a critical number where f prime of x is undefined. We have a denominator as a piece of this derivative, and that denominator is x to the 1/3. So wherever that is equal to 0, that will be where the derivative is undefined. Again, cube both sides and you would get the answer x equals to 0. Notice that we only need to use the critical numbers that are in the inside of our closed interval, and both the x equals to 1 and 0 are inside the closed interval -1 to 3. So we will be evaluating the function at those values. Let's go ahead and do some evaluations here. Let's start with, let's say, the endpoints. If I look at f of -1, this is going to be 2 times -1 minus 3 times -1 to the 2/3 power. That's going to end up being -2 minus 3, which will be equal to -5. If we do f of 3, this is going to be 2 times 3 minus 3 times 3 to the 2/3, which is going to be 6 minus, one way you can write this is going to be 3 to the 5/3 power. And we'll get a calculator out in a minute to approximate that. We also need to evaluate the function at the critical numbers. if we look at f of 1, this is going to be equal to 2 times 1 minus 3 times 1 to the 2/3. That's going to be equal to -1. Let's get some more room here. And f of 0, which was our other critical number, this should be 2 times 0 minus 3 times 0 to the 2/3, and that will be equal to 0. If we wanted to approximate the f of 3 value so we can kind of compare it to the other numbers, we would need to use a calculator for that. If I do 6 minus 3 raised to the 5/3 power, it's going to be approximately -0.24. So looking at this list of values we get, the smallest value is going to be the output -5. So we have a minimum of -5. And that occurs when x equals -1. So remember, when we're talking about mins and maximums, those are always the values of the function. In addition to saying what the min and max value is, we would always like to kind of say for which values of x those mins and max occur at. So in terms of giving the information, you could just say f of -1 equals to -5 is the minimum, or to be more precise, it's a minimum of -5, either at, or you could say when x equals -1. The maximum output we got from this was the 0 value. So we have a maximum of 0, and that occurs when x itself was equal to 0. So this is kind of a good recap of the kind of things we did before our class went on break. Again, define the extreme values of a function on a closed interval. If the function is continuous, that is. Then you need to find the derivative. Use the derivative to find the critical numbers. Those are the places where the derivative is equal to 0 or undefined. You use those critical numbers which lie in the inside of your closed interval. You evaluate the function at the endpoints, the function at the critical numbers, and your max and min will come from that list of outputs. Let's take a look at one more. Same thing, in example 4, we want to find the extrema of the function f of x equals 2 sine x minus cosine 2x, and we're going to look at this on the interval 0 to 2 pi. So first thing we'll do, let's go ahead and find our derivative. F prime of x is equal to 2. The derivative of sine is cosine. It's going to be cosine x. And then the derivative of cosine, that's going to be negative sine 2x. And then from the chain rule, we have to multiply that by the derivative of the inside, which will be 2. So f prime of x is going to be equal to 2 cosine x plus 2 sine 2x. Okay. We now want to find our critical numbers, so we want to know where is f prime of x going to be equal to 0. So where is 2 cosine of x plus 2 sine 2x equal to 0? Well, one of the things that would help us to solve this trigonometric equation is to use the identity. We can swap out the sine of 2x. You might recall from trig that the sine of 2x is 2 times sine times cosine. And by using that double angle formula, we get rid of the double angles. So wherever I see sine 2x, I can put 2 sine x cosine x is equal to 0. This is 2 cosine x plus now 4 sine x cosine x equals to 0. We can now go ahead and pull out a GCF. We can factor this. Both terms have a GCF of 2 cosine x. This will leave us with a 1 plus 2 sine x equals to 0. And then from here, just go ahead and set each of those factors equal to 0 individually. So we have 2 cosine of x equals to 0, and the other one was 1 plus 2 sine x equals to 0. For the first equation, just divide both sides by 2. We get the cosine of x equals to 0. The solution to this equation between 0 and 2 pi would be x equals pi over 2, and also x equals 3 pi over 2. For the second equation, we need to get the sign by itself. You would just subtract 1 and then divide 2 to both sides. We would get that the sine of x would be equal to negative 1/2. The sign is negative in quadrants 3 and 4, so you should get 2 solutions for this as well. The first one is going to be 7 pi over 6, and the second one would be 11 pi over 6. Okay. So those are our critical numbers where the derivative is equal to 0. You could ask, and we should do this, but we should ask to see where is f prime undefined, and that will not produce any solutions. This derivative, if you look at f prime of x, it just consists of a bunch of cosines and sines, and we know that those two functions have domain all real numbers, so this derivative will be defined for all real numbers. It won't be undefined anywhere. So now that we know what our critical numbers are, we also know the endpoints are 0 and 2 pi. We're going to go ahead and evaluate this function at those points. So let me start with the endpoints because those are going to be the easiest. F of 0 would be 2 times the sine of 0 minus the cosine of 2 times 0, which is 0. Sine of 0 is 0. Cosine of 0 is negative 1. Is 1, so that's going to be negative 1 for the final answer. F of 2 pi. I'll let it up to everybody individually, but I'll let you check this on your own. That will also have the output of negative 1. We now need to check the function at the critical numbers on the inside of the interval. F of pi over 2. This is going to be equal to 2 times the sine of pi over 2 minus the cosine of 2 times pi over 2, which would be pi. The sine of pi over 2 is 1. The cosine of pi is negative 1. So we get 2 minus negative 1, which is 2 plus 1, which will be 3. F of 3 pi over 2. This is going to be 2 times the sine of 3 pi over 2 minus the cosine of 2 times 3 pi over 2, which will be 3 pi. The sine of 3 pi over 2 is negative 1. 3 pi is coterminal to pi, and we know that the cosine of pi is negative 1. So we're going to get negative 2 minus a minus 1, which would be negative 2 plus 1, which is negative 1. We're now going to look at f of 7 pi over 6. This is going to be 2 times the sine of 7 pi over 6 minus the cosine of 2 times pi over 6, which is, 2 times 7 pi over 6. That would give you 7 pi over 3. The sine of 7 pi over 6, that's going to be negative 1/2. So this is going to be 2 times negative 1/2, So this value here is going to be negative 1. Subtract. Now 7 pi over 3, that itself would be coterminal to pi over 3. And we know that the cosine of pi over 3 is a half. So this whole value would work out to be negative 3 halves. And then lastly, if we look at f of 11 pi over 6, this is going to be 2 times the sine of 11 pi over 6 minus the cosine of 11 pi over 6 times 2 is going to give us 11 pi over 3. Let's work that out. The sine of 11 pi over 6 is negative a half. 2 times negative a half is negative 1. Subtract. Now 11 pi over 3, that's coterminal to 5 pi over 3. And the cosine of 5 pi over 3 is still going to be, it's going to be a positive half. It's going to be a positive 1/2. So that would work out to be negative 1 plus a half would be a negative 1/2. So we've evaluated the function at the endpoints. We've evaluated it at the critical numbers inside the interval. When we do so, we see that of all of those values we got, the maximum value was 3. So that's our max. And that occurs when x is pi over 2. The smallest output we got was negative 3 pi over 2. That's our min. And that occurred when x is 7 pi over 6.